What if I told you that a simple number, the square root of 2, once shattered the entire foundation of ancient mathematics? Today we are going to uncover the shocking truth about why this seemingly innocent number is actually impossible to express as a simple fraction. Let us start with the basics. Imagine a perfect square with sides of length 1. Using the Pythagorean theorem, the diagonal of this square has a length of exactly square root of 2. But here's where things get mind-blowing. This number cannot be written as a fraction of two whole numbers, no matter how hard you try. First, let us understand what makes a number rational. A rational number is simply any number that can be written as a fraction, a over b, where both a and b are whole numbers. And b is not 0. Think of simple examples like 1/2, which equals 0.5, or 3/4, which equals 0.75. Now here is where it gets interesting. We are going to prove that square root of 2 is irrational using a brilliant technique called proof by contradiction. This method is like detective work. We assume the opposite of what we want to prove, then show that this assumption leads to an impossible situation. Step 1. Let us assume that square root of 2 is rational. This means we can write it as a fraction a over b, where a and b are whole numbers with no common factors. In other words, the fraction is in its lowest possible terms. Step 2. Now we square both sides of our equation. Square root of 2 squared equals 2, and a over b squared equals a squared over b squared. Multiplying both sides by b squared gives us 2 times b squared equals a squared. Step 3. Here is where the magic happens. Since 2 times b squared equals a squared, this tells us that a squared is an even number. But here is a crucial fact. If a number squared is even, then the original number must also be even. Why? Because only even times even gives you an even result. Step 4. Since a is even, we can write it as 2 times k, where k is some whole number. Substituting this back into our equation, 2 times b squared equals 2k, all squared. This simplifies to 2 times b squared equals 4 times k squared. Dividing both sides by 2 gives us b squared equals 2 times k squared. Step 5. And here's our contradiction. This equation tells us that b squared is also even, which means b must be even too. But wait, this is impossible. We started by saying that a and b have no common factors. But now we have shown that both a and b must be even, meaning they both have a factor of 2. This contradiction proves that our initial assumption was completely wrong. Square root of 2 cannot be written as a fraction of two whole numbers. It is, without a doubt, an irrational number. This discovery was so shocking to ancient Greek mathematicians that legend says they tried to keep it secret. It challenged their fundamental belief that all numbers could be expressed as ratios of whole numbers. If this proof amazed you as much as it amazed mathematicians thousands of years ago, smash that like button and subscribe to MathVar for more mind-bending mathematical discoveries. And here is a challenge for you. Can you use this same method to prove that the square root of 3 is also irrational? Drop your attempt in the comments below. Remember, mathematics is not just about numbers. It is about discovering the hidden truths of our universe, one proof at a time. Until next time, keep questioning everything.